Luke Skywalker, I am your father. Now, I know you all are a little concerned about working with uranyl nitrate. It's really not that bad as long as you follow the proper precautions. Welcome to Barbados, the island in the sun, one of the most beautiful tourist destinations in the entire Caribbean. And welcome to my modest little darkroom, where today we'll be discussing Uranotype, a process that was patented in the mid-19th century and was very popular until the end of the 19th century. Disclaimer, this is not an exhaustive study. It is at best an introduction to a lovely old process that needs a lot further experimentation and research. I've been researching and experimenting with this process for just a few weeks, so I do not claim to be a master. Let's approach this in the manner of the early Heidelberg University, where no one presumed to be a master, but instead people came together as a group of intelligent, creative, highly motivated people seeking truth, beauty, and knowledge. In this process, we use uranium nitrate created from depleted uranium, which is mostly U-238, the least radioactive isotope with the longest half-life. It results from reaction of nitric acid, and it is done to assay depleted uranium. Other than the safety precautions, this is one of the easiest processes that I have ever done. Do not, I repeat, do not use self-mined pitchblende as Blake Ferris did, which is much richer in U-235 and therefore much more radioactive. On Steve Geirish's YouTube site, you can see the Geiger counter clicking away because the print is so radioactive. I have a reference here. You can find it in your printed notes. Bob Schramm said that he used a lab-grade Geiger-Muller counter and got no scintillations whatsoever from his uranotypes. I tested one of my prints using a highly sensitive scintillation counter in the physics lab at the University of the West Indies, and at 4 inches from the center, it showed about twice as many scintillations as the background radiation, which is a very small amount. At 12 inches from the sensor, the level was only a few percent above background. So the risk of radiation is relatively small in a finished print. But it's not the radiation of the U-238, but the extreme toxicity of uranium salts and uranium ions that we're concerned with. The actual image in a true uranotype, as opposed to a uranium print that uses photosensitivity of uranium to reduce other metal ions to neutral metal ions, and where the uranium washes out, is made of the orange pigment uranyl ferrocyanide. One of the extremely fun things about the uranium print, the uranotype as it were, is that it has an extremely long exposure scale or scale index. By that I mean you need a density difference of 2.5 and up to 3.0 in your negative to use the full tonal range of a uranotype. I feel it reasonable to give credit to the sources that I used when I did my research. Including myself, there seemed to be 6 practitioners of the process, one of whom died. Most of my information came from Bob Schramm, both his webpage and the numerous phone calls that he patiently listened to my problems and gave me so much free advice. He was very, very helpful in this. The second source is Blake Ferris's former website and the YouTube that I cited above, and other web articles on him. As I mentioned, he mined his own pitchblende, which is a dangerous mix of all of the isotopes of uranium and therefore highly radioactive. The YouTube shows one of his prints causing a Geiger counter to crackle away, meaning that it is a highly radioactive print. He lived in Los Angeles, and I found an obituary for Blake Ferris in LA at 43 years old, dated May 4th, 2011. I have not been able to find a cause of death. I hope it has nothing to do with uranotypes. Another source was the Morgan Post website. Morgan Post makes some beautiful uranotypes. Another source was the Steve Geirish YouTube, which shows Blake Ferris's radioactive print. Chris Hagbloom is on the Alt Photo site, and there's a very old document from the 19th century. Let's see if I can pronounce this correctly. P.C. Duchossois, I assume he's French, so it would be Duchossois. Photographic Reproduction Processes, a practical treatise of the photo impressions without silver salts for the use of photographers, architects, engineers, draftsmen, and wood and metal engravers. Okay. In terms of historical background, the first known experiments of uranium as a photosensitive salt were done by J. Charles Burnett in the early 1850s. The source for this is Wikipedia. Uranotype paper was manufactured and sold to the public soon after this, around the 1860s, and all the way literally to 1899. I believe that's the last time that uranotype paper was sold. A photographer could go into a photo store and buy platinotype, silver gelatin printing out paper, and uranotype paper right in the Photoshop. And I don't mean CS5. One wonders why people would do this. Because of the beautiful color, that sort of old rose or that old burgundy, purpley brown color. It was extremely popular for portraits, individual portraits and family portraits. People love that very warm color. In terms of safety concerns and precautions, the developer is potassium ferricyanide, and it's relatively benign. Same stuff you use to mix a cyanotype, and we all know cyanotype is one of the least toxic of all the alternative processes. As I mentioned, uranium U-238, uranyl nitrate, does release a small amount of beta particles. Those are high energy electrons, not unlike sitting too close to your TV set if you have an old CRT. But of course, commensurate with any decay, particle decay, are small amounts of gamma radiation. I keep these in a lead house. One of the best ways to do it, remember you all used to have these and you probably threw them away. Well, if you're like me and you're a pack rat, you keep everything, you can now put them back to work. The lead film bags that you used to use to travel with film through airport x-ray, now you can keep your uranyl nitrate in there. It's more than sufficient to protect it. I actually went to the extent of making a little lead house. It's lead from a roof on a church. There's the lid. And here's the house. And you can see inside of the house I have a plastic jar that holds my smaller jars of uranyl nitrate. So that's how I keep my uranyl nitrate safe. And of course, as soon as I'm done with that, I wash my hands. Okay, so given the uranyl nitrate, what do we do? Okay, when I'm mixing the uranyl nitrate, that means I'm actually using a spatula, taking the uranyl nitrate that I've measured on the watch glass on my digital scale and mixing it into some distilled water right here in the graduated cylinder, and I stir with a glass rod. Now, but I don't do that with bare hands. This is what I do. The first thing I do is an OSHA approved, good catch, huh? An OSHA approved mask with respirators. I think it's level 3, it could be level 5, I'll double check. Test to make sure it's working. Can you still hear me? Put on my reading glasses, otherwise I imitate a bat. And then on goes my protective goggles. Now, to handle the chemistry, I have very large, elbow-length nitrile gloves. Smart move is to bend the tops down a little bit so nothing can drip up your sleeve. We're not going to do that now because I'm just showing you. But you fold it so nothing can drip up your sleeve. Then you measure your uranyl nitrate. Dissolve it and pour it carefully. Bring your volume up, in my case to 48 millimeters. And pour it carefully into your brown bottle. Rinse it, label it, store it, carefully wash. Now notice, when removing the gloves, you don't touch the ends. What I would do when I was done, I'd rinse, wash, now what I also often do is this. I actually rinse down my hose once the gloves are rinsed. Make sure that anything I've touched with the contaminated gloves has been rinsed off. And then, before I remove the gloves, I take a paper towel, wet it, and actually use it to wipe the faucet so there's no residual chemistry left on the faucet, so it's not toxic. Then you throw that away.
Now, the removal of the gloves is important. You can't grab these gloves with bare hands. So you start pulling, and then you pull, sort of like scooping the poop in reverse. Then you pull, and you pull, and you hold them by that. Then you hang them up to dry. Now, I'll put them here for now, since we didn't handle any chemistry. Your next move is, okay,
Your greatest risk with the uranyl nitrate is the crystals. Now, thank God it's crystalline and not powder, so you don't often get a lot of stuff floating around the air. You don't get a lot of powder unless you shake it up or grind it or something, so we don't usually do that. Once it's in solution, your bigger risk is going into the eyes, which gets it right into your brainstem and it's going to ruin your day, or getting on your hands. So when I'm coating, I wear simply goggles. Well, reading glasses first. Goggles. And then for coating, you'll see I wear, and I'm going to give you a coating demonstration in 1 second. For coating, I wear 2 nitrile, and this is very important. You need nitrile. Latex is not good enough. Vinyl is not good enough. Nitrile has a higher puncture resistance and less permeability to toxic chemicals. Nitrile gloves, which I'll put on when I'm actually showing you the coating steps. So that's what I do for coating. When I'm processing, because the print is already dry and you're only working with potassium ferrocyanide and a very small residual amount of uranyl nitrate in the print, which won't have been bound to the ferrocyanide within a few seconds of being developed, then I just wear the gloves because there's a low probability of getting uranyl nitrate into your eyes. Okay, now in reference to mixing the chemistry, the good news is that both chemicals are highly soluble and there's no heating necessary. As a matter of fact, with the uranyl nitrate, it is inadvisable to heat the solution. The sensitizer coating solution, you wearing a respirator, protective eye goggles, long sleeve shirts, large elbow length nitrile gloves, right up to the elbow, and in the same proportion of Bob Schramm's formula on his webpage, it's also in the Unblinking Eye webpage, I mixed 16 grams of uranyl nitrate into 48 milliliters of distilled water. I actually mixed it right in the graduated cylinder with a glass rod. So I could start with about 35 milliliters of water, put in the uranyl nitrate that I measured carefully on a digital scale, and then I simply stirred until it was dissolved, tapped off the residue off the rod, put it immediately into the sink to be washed, and then I brought the volume up to 48 milliliters, poured it into a dark brown glass bottle, capped it off tightly, and that's it. According to Bob Schramm, his lasted years in a tightly capped bottle. It's not something that seems to oxidize quickly. The only couple of provisos here are, number one, be sure you wash all of the glassware very carefully and thoroughly and wipe it. Don't just put it to dry, wipe it so there's a minimum residue of uranium on it. One other thing is uranyl nitrate is a pretty strong oxidizing agent, so it's recommended you do not, I repeat, you do not use a plastic or paper, a plastic dish or a paper filter paper when you're measuring it. Now, standard procedure with less active chemistry is to put a piece of filter paper on your scale, tap your chemistry or spoon using a spatula, put your chemistry on to the proper mass, and then pick up the filter paper and put it into your solution. Uranyl nitrate is a pretty strong oxidizer and you have a risk of fire. Last thing you want is to have a fire and to release uranyl nitrate into the air. That's lung cancer just waiting to happen. So I used a watch glass, which is pretty standard lab procedure, simple circular piece of watch glass, spooned with a spatula the uranyl nitrate into the watch glass until I reached 16 grams, and carefully then used the spatula to put that into the graduated cylinder, stirred, and done with that. That's the tricky and nasty one. Now the easiest one of all is a developer. Again, in proportion to Bob Schramm's recommendations, I mixed 33.4 grams of potassium ferrocyanide into 1 liter of cool distilled H2O and stirred. In 4 minutes, it was completely in solution. I poured it into a brown glass bottle, and as we say in Barbados, done with that. Okay, what we have here is a sheet of 1114 Crane's Platinotype natural paper. You'll see that I have on my thin surgical nitrile gloves or exam nitrile gloves. Again, more puncture resistant than either latex or vinyl. And here's the paper. I tape it down onto my coating surface. This is my little coating station here for platinum palladium. Actually, for all my alt processes, I just keep it clean and use it for whatever I'm working on that day. Now, the next thing I'm going to do is I'm going to make notes, and that is I put in the date, and this is the third sheet of paper I'm coating today. And then I'm putting the mix. In this little cup, I've mixed 4 milliliters of uranyl nitrate, 1 drop of PVA, polyvinyl alcohol, 3 drops of pure alcohol, just to help it soak in and coat, and then 8 drops of potassium dichromate as a contrasting agent to snap up the highlights. I just call it dichromate because it's the only one I got. I don't have the ammonium or the others. So now I've made my notes. Here is my coating brush. This is a Richardson Magic brush. I have painted, before using it, I painted this area. You may see the gloss, and the top, you can see this strange little discoloration. Painted this with a clear vinyl to keep the chemistry from interacting with the ferrule, I think that is called. And now I step down here, and I just carefully shake the water. That brush has been sitting in distilled water. 3, 4, 5, 6. Just enough so it started to break up a little bit. Let me do it again. I don't like when it breaks up. I'll try 5 shakes. 1, 2, 3, 4, 5. Ah, good. Now the brush is all together. So as I said, 4 milliliters uranyl nitrate, 1 drop PVA, 3 drops pure alcohol, 8 drops potassium dichromate. Now folks, most of you who have done alt process will see it's the same thing. You do every day. You work with cyanos, albumin, salt, unless you float your boat with those, platinum, palladium, etc., etc., etc. It's the same process. The difference is that I find that this mixture is so much less viscous than the others. It's extremely fluid. The solution is almost like pure water, and it takes a while to soak in. So I pour it on, shake it, and I carefully set this down. This is highly toxic, and I probably have some uranyl nitrate on my fingers now. It's quite dilute, but it's still toxic, so I'm going to be very careful. Now I just start circling the outside, establishing my edges, and then I just keep painting. You all know this. I'm sure you all have done this before. I keep doing back and forth, leaving as few puddles and drops as possible. Then I do the vertical one, trying not to run off the paper. Up, I did a little off the top. Now while I'm doing this, I'm going to talk about another issue. The issue is the tailings. I'm sure that some of you in the audience are saying, yeah, but what happens to everything that goes down the drain? Well, wherever you live, you will have to conform to the standards of your community. However, here in Barbados, as I mentioned repeatedly, we have a lot of calcium in the water. And one of the most interesting things you can do is take anything like palladium, platinum solutions, uranium solutions, any of those solutions, and just add a little tap water. And all of a sudden you get this sometimes white, sometimes yellow, sometimes beige or red or brown sludge. So the only good thing I can say is that any tailings that do happen to wash away from the very small amount of uranium I use precipitate out with the calcium carbonate, and I'm sure are sitting as a sludge on the edge of our cesspool. They are not going into the groundwater simply because they precipitate as a sludge. Now, that may be a concern when it comes time if we have to clean the cesspool. I can get a reading done and make sure it's not important, but then again, the amounts we're using here are so small, so minuscule, that it's probably a relatively low problem of either radioactivity or toxicity. And that's pretty much it. There's very little running around. Now what I will ask my assistant, who's hiding carefully behind the cameraman, to do is to pass me a piece of paper towel, because I ran over just a little bit. And then what I'm going to do with that paper towel is wipe off the excess it has not yet soaked in, and also pick up a little bit where I ran over the edge. Now, you'll see there's just this little shiny excess here. I'm just going to wipe that. I'm going to put the brush into the distilled water. And I think I ran over the edge. No, it doesn't look like I did, but I'll be cautious anyhow. And I run this under the edge of the paper and along the coating surface to make sure there's as little uranyl nitrate floating around as possible. Now, I remove these tapes now, but I don't know if Stuart can see this, but if you look, I look at this angle, and this looks very shiny, which means that most of the uranyl nitrate is still, the coating solution is still sitting on top of the paper. The results of that are actually a bit, if I go like this, carefully, and hold this around the back as a mirror, Stuart will be able to see a reflection of this on the paper because the paper is still so wet. You see, now what we do is, I leave the paper to sit and let the coating solution soak in. It's starting to soak. There's still a little excess right there, so I'm going to daub that. Leave that there because I'm going to clean this whole coating surface when I'm done. Now I go down here, and the first thing I do, try not to step on the microphone cable. First thing I do is I flush the brush with tap water. Flush the brush. Handle, ferrule, everything. Dump. Second flush. Rinse, rinse, rinse. Back and forth. Flush. Once more time. And then, pretty much flushed out most of the coating solution. I give it the usual shake. Rinse my gloves to remove the excess. Whoopsie. Grab myself, turn this off. And then grab myself. One of the greatest expenses I find is distilled water. Electricity is so expensive, it's expensive to have a still. And it's pretty expensive to buy distilled water here. So I give the brush a good flush in distilled water to get the calcium carbonate that was in the tap water out. Shake it out again. 2, 3, 4, 5, 6, 7, 8. I set it in here. I dump in a little more distilled to keep the brush wet for the next coating. Okay, I've rinsed my gloves, so they're relatively non-toxic. I'm drying them on this towel, which will be washed separately. I wash all my darkroom towels separate from family laundry. And now I'm going to lean down here again and look to see if there's any shininess left on the surface of the print. The reason you don't want it shiny is shiny means that there's fluid coating solution still lying on the surface. And if you lift it up and hang it to dry, that solution will run in drips. And the results are you'll have an uneven coating and it could ruin your image. So I'm looking, and all I see is a sort of humid-looking matte surface, which means we're coated. I take it up. Oh, there's a little wet there. Hold on. I think I can cheat and just dry it because it's right on the edge. Okay. And there too. When it's on the edge, it's not in an image area, then it's nothing to worry about. Okay, that's it. So I take it, I usually hang it by the numbers, and there you go. Now what we do is, I then leave this to dry in the dark for a full hour. If I'm coating more paper, now that this isn't dripping, I will clean this surface, coat another piece, hang it next to it. But either way, the last piece coated hangs a full hour in the dark. There are a couple of things that I need to tell you about coating. Number one, do not, I repeat, do not use a blow dryer. The hot air, the blow dryer, the force of the blow dryer can force particles of uranium to blow off the print surface and into the air in your darkroom. You will sooner or later inhale them, and there's a very high possibility that you'll get lung cancer as a result. You just don't want to do it. And even if you don't get lung cancer from the radiation, you will get some of the uranium into your bloodstream, absorbed through the lungs, and you will have neurological damage as a result of the fact that uranium is a neurological poison. So you do not ever use a blow dryer to dry a coated print. You just let it be. Okay? You let it air dry here and you hang it up there. This is one of those processes where you need to be a good parallel, what they call it, a multitasker, someone who understands parallel processes. You know you're going to have an hour where you can't work in the darkroom. You go out and you Photoshop the next scan, you print out the next digital negative, you spot or flatten the next print. But you do have to give yourself that full hour of drying, preferably in the dark or at least under the bug bulbs while you're coating another one. I usually coat 3 or 4 pieces at a time. By the time I finish coating the 4th one, I usually have about 15 minutes till the first one's up for an hour. I just leave them in the dark for a whole hour from the last one and put them into this box. This is an example right here. Here's a box, and here are some coated sheets in here. Here's a sheet coated exactly the same formula early this morning. 4 milliliters uranyl nitrate, 1 PVA, 3 alco, 8 dichromate. Exactly the same thing, but I coated that one earlier this morning before the shoot started. And folks, I think that's it for the coating department. Okay, here we are. The paper is dried at least 2 hours, and we're about to expose the paper in my plate burner. It's a 26-1K Newark exposure system. It's a metal halide plate burner. Now, a couple of things. Number one, because doors are closed and we are again under the bug bulbs, same lighting I used to coat, for the same reason, because bug bulbs absorb UV and the mosquitoes don't chase you for that reason, or the flies don't chase the bulbs. Now, I've also turned on the exhaust fan. Whenever I close up, I put on the exhaust fan. I have a light tight intake vent and an exhaust fan up there that takes the warm air out that we exhale, or that comes off warmer solutions, or the ozone that comes off this metal halide plate burner. Now, I have made Uranotype prints, which you will see, both from camera original negatives. For example, the lilies are camera original negatives. They're 5x7 Tri-X developed in PMK. And I'm also making prints from digitally enlarged negatives, Dan Burkholder system, ink press film. I scan them with my Epson 750, Pro 750. I work on them in CS5, and I print them out with a Epson 3800 with the Ultrachrome permanent pigments. So here's an example. This is the one Madonna con la Bambina. You probably can't see much there, but you can get the idea. So I'm going to set this right here for a moment. I'm going to open the plate burner. I have, just before we started rolling, I have used a hair dryer to dry this. Here in the very humid tropics, you get a lot of moire rings if you don't, and Newton rings you call them, and they will leave funny gray patterns on your print. So I set the negative in there carefully, like so. Then I slip into, these are a pair of gloves that I just keep around. They're vinyl. It's not as critical. I just don't like touching the uranium-coated prints, the uranyl nitrate prints. So I slip these on. I got a little powder in them, just while I'm handling the coated paper. As I said, minimizing my exposure is a good idea. And you know something? I think it has a lot to do with how often you make prints. I'm making a lot of uranotypes, so I'm going to be handling this for a lot of time. Handling a lot of uranyl nitrate coated prints, so I tend to want to be careful to minimize my exposure to the uranium. If you don't do it often, maybe that's different, but as I said earlier, I err on the side of caution. So we open the plate in, we lift up. I have a very, very thin acetate, which is actually half of a clear bag plastic bag. I take the clear bag plastic bags and split them in half, and I get 2 separation sheets out of it. They're incredibly thin, and I have never seen any loss in resolution as a result. I position the negative over the the coated part of the paper. I've coated right out to the edge of the paper, so that should be pretty good right there. And make sure I've got the foggy side up and the sharp side down. That is correct. Try to square it up nicely, even spaces top, bottom, parallel to the edges. Looks good. Now it's going to get a little noisier. I'm going to turn on, and I'm going to give this, because of the tests I've done, 2 exposures of 999.9 units. It only goes up to 999.9 units, so I have to hit it twice to give the proper exposure to get a Dmax. The process is relatively slow. So I've got that set to 999.9. I have now locked the vacuum frame. I've locked it, and once I hit this button, it's going to get real noisy, and you're probably not going to be able to hear me anymore. But all I have to do is, after the vacuum comes up to the green range, showing that it is has a good vacuum, I will then hit the start button, pull the curtain across to minimize my exposure to ultraviolet, and leave the room. Because, as I said, I do this a lot too, and I'm not interested in skin cancer or cataracts, which can result from UV exposure for the aqueous vitreous humors and your lenses in your eyes. So here we go. I'm ready to go, and it's going to get noisy. There we go. I assume you can still hear me above this. It's crawling upward. 5, 10, 15, approaching 20 inches of mercury. It's in the green zone. Not in Iraq, thank God. It's in the green zone. And I start to pull the curtain across to minimize my exposure and hit it. And there we go. We're exposing. Okay, here we are. Under the bug bulbs. The reason I choose bug bulbs, again, perhaps I'm more cautious than I need to be, is bug bulbs absorb ultraviolet, and ultraviolet is what attracts flies and moths and things at night. You all have sat out on your front porch under bug bulbs to keep them from attracting the bugs. So if it filters out the UV, I figured it would minimize the chance of fogging any of our alternative processes. Now this one is a very low sensitivity process. As I mentioned, it took 2 hits of 999, that's 1,000 units, a total of 2,000 units to expose this uranotype. So probably, again, I'm being overcautious, but I can see what I'm doing, and I don't lose any sleep over using this. Now, you'll notice I have my tray. You can use a larger tray, I don't find it necessary, and I have a little piece of plastic mosquito netting in there, not because of the bug bulbs, but because it adds strength, wet strength to the paper. So I simply set my print on top of the mosquito netting. Here is the potassium ferrocyanide developer, mixed as according to my instructions earlier. I set the timer for 6 minutes and 6 seconds, and as the timer comes up to 0, I simply pour it on. Slosh it around as much as I can. Cover everything as much as I can. Now, one of the things you'll see that's very interesting is when you have used this paper, as I mentioned earlier during the coating session, this paper was coated using an 8 drops of potassium dichromate. You have your 4 milliliters of uranyl nitrate, you have 1 drop of PVA, 3 drops of alcohol to help the coating, and the 8 drops of contrasting agent, the 1% solution of potassium dichromate. Now, one of the things that's cool, let me turn this around for the cameraman to see. Look how white the highlights are. Notice in these areas the highlights are white and detailless, and that is okay at this early stage because you'll notice there's no such thing as a Dmax in this print yet. We're barely 45 seconds. You don't have to go hog wild on agitation. I found it doesn't seem to make any difference. I have the habit from platinum palladium printing of lifting and draining. I don't know if it's necessary. I do it anyhow. I lift, I drain, and then I turn it over. I keep it going. We're at 1 minute. And you'll see that the Dmax builds up very slowly, as do the highlights. Actually, you'll notice we're probably going to skip, probably going to dissolve in a minute to 2 minutes from now, and then dissolve in a minute to the last minute when the Dmax is at max. But I'll show you again just before we dissolve out of this shot that here you can see we still do not have much of a Dmax. So let me just lift that up so Stuart can get a view of it. See? Stuart, our excellent cameraman and producer today, you see there's not a lot of Dmax. It's still quite grainy looking. You can see the paper texture through it. And the highlights are very, very white. There's no texture or tone in them at all. All right, Stuart, why don't we dissolve out of this? Okay, here we are about a minute and a half later. You can see the Dmax is coming up. The highlights are still very white, but still there's a tiny bit of tone coming in. Okay, I'm going to flip it over. And I'll bring it back up so you can see it again. You'll see we're now going to halfway through the process. You can see the Dmax is coming up, but you'll notice that there's still a lot of texture. There's still a lot of paper texture in there. It is not yet fully developed, and your whites are still completely white with no tone or texture in them. So, okay, we can dissolve out of that now. I've decided to let this go an extra minute because the dichromate, I forgot, slows down the development of Dmax a bit. Notice how you are almost getting a deep purple, but you've definitely started to pick up a little tone and texture in the highlights. So you're getting a much more full-toned print. The highlights are still quite light, but we're now going into the 7th minute. We're going to just keep the development going. And as soon as we finish, we're going to dissolve out of this, and then we'll show the wash process, which will be the next step after this. There's no other processing necessary. You simply develop and wash. That's it. Okay, Bob Schramm and I discussed it, and I poured the developer back into the bottle. He said I could easily get 5 or 6 11 by 14 uranotypes out of 1 liter of the potassium ferricyanide. I've dumped them at 6, but I never saw any lack in Dmax. Now, I'm putting in a couple liters of water here with 1/4 teaspoon of citric acid, and that's all it takes. I take the print and I give it its first 1-minute soak in the water with citric acid. That's all there is to it. There's not much excitement here. You set the timer. I set the timer for 10 minutes. And I do a 1-minute soak, and a 2-minute soak, and a 4-minute soak, sequentially, all in a couple liters of water with a 1/4 teaspoon of citric acid. The reason is my water here, the water here in Barbados, the aquifers exist in coral stone. Our island is a coral stone island, not a volcanic island like St. Lucia and some of the others. It's a coral stone island, with the results are that we have an enormous amount of calcium carbonate in our water supply, which makes the water supply slightly, or perhaps more than slightly, alkaline. And the results are that, like a cyanotype, these prints bleach. The first time I did it, I didn't get much Dmax. And then ever since then, I started tossing in this little bit of citric acid, and from then on, I kept a very beautiful deep purple Dmax. So I don't know the science of it. All I can figure is something in the alkaline changes the ferrocyanide or something. I don't know. Whoever knows more about cyanotypes could probably conject, because it's very similar. So I leave it in for the first minute. Coming up now, I stop the timer. I lift and drain. I just rest it in that tray. I dump this. Give it a quick rinse. See, the problem is, because we have all this calcium carbonate, I can't do a running wash. I would have to, maybe someday I'll figure out how to fill this print washer with water and citric acid and just dump out, or let it trickle out a little bit at a time. But in the meantime, I do a multiple rinse and dump. 1 minute, 2 minutes, 4 minutes, and then 2 4-minute treatments of distilled water. And you basically have it. Now, I'm not going to bore you all and make you watch that, but we'll give you a couple of examples of this, and then I'll show you it sitting in the distilled water treatments, and you'll have the idea. Once it's done washing, it's hung to dry. Again, 1/4 teaspoon of citric acid. I buy it in the 5 kilogram bucket. You can get it, most suppliers, food suppliers have it. It'll work for what we're doing. And again, put it in, turn the timer back on. We're now going for 2 minutes. And I rinse the holding tray so we don't have any residual from the previous rinse. And there you have it. What is interesting is you'll see, again, under this yellow light it's quite hard to see much of it, but once the white lights come on, you'll see that once it hits the acid, the color seems to jump up a bit. But now you can see you have beautiful tone in the highlights with texture. and the deepest Dmax you're going to get from this development process, and there it is. All right, here we are. This is now the end of the 4-minute soak. There was 1 minute, 2 minutes, 4 minutes in separate baths of water with a 1/4 teaspoon, tap water with a 1/4 teaspoon of citric acid. Now the first thing I do is I take the print, I lay it in the bottom of a rinsed tray, and I give it a quick rinse, just a rinse, with distilled water, just to get as much of the citric acid and other water off it as you can. You dump that and drain, let it drain, get as much of that residual off as you can, because some of it is on the screen in the back, so you let it drain as much as you can. Then you drop it in gently. Now you cover it well with distilled water and let it sit for 4 minutes. And in 4 minutes you do the same thing again. You simply rinse it and pour in more distilled water, let it sit another 4 minutes. And rather than waste your time watching a print soak for 8 minutes, we're going to cut away. What we have here is the print. It is now exactly, click, finishing its second 4-minute soak in distilled water. So to review quickly, 1 minute in citric acid tap water, 2 minutes in citric acid tap water, 4 minutes in citric acid tap water, and then 4 minutes in distilled and 4 minutes in distilled. Now this is the last of the 2 4-minute distilled. I'm taking a piece of paper over so it can drip onto it, not splash around the darkroom. And I just clip these babies up like this. And you simply leave it to dry. That's all she wrote. And that's it. That's all it takes. As I said, the thing about the Uranotype is that it isn't a complex process. It's easier than silver gelatin, easier than platinum. The only one easier is cyanotype, because you don't even develop that. You stick it in the water. That is the developer. The wash is the developer. So that's the only one that's easier. But the only thing that makes this a little touchier is the toxicity. And as long as you handle that, it's a very simple process. And I think if we move in here, let me lift these out of the way. Move in here and take a look at the color. It's a beautiful, beautiful color. Sadly, it'll dry a little more muted and a little browner, but I still am fascinated by that color. Now, one of the things I love are the aesthetics of these images. What looks best in this color? A number of the sources that I quoted above mentioned that 19th century consumers loved Uranotypes and preferred them for portraits. They love that old rose or old burgundy color. It's sort of a brownish purple, sort of like a glass of wine you've left out too long or in the fridge too long. And they loved it for family and individual portraits. I think I mentioned this before. And also, I have tried a couple of different things. I've tried a portrait, Madonna con la Bambina. I tried Sangiovese grapes from Antinori Vineyard, Santa Cristina. I will have made, when you see this, you will be able to see a print of wine and roses. I've made a print of lilies. And I hope to print an infrared image of my Zen garden in Uranotype. And what it'll do is, hopefully, it'll turn my Bajan cherry trees and my bamboo trees into looking like Japanese maples, because they'll all be red. We'll see. Now on to the topic of toning. I couldn't find anything in the literature on toning Uranotypes. Now there's lots of wonderful options on toning silver gelatins and platinum palladiums with uranium toners, but I could not find anything specifically about toning Uranotypes. So I decided to go off into the unknown. The first thing I tried was a palladium toner, which will be in the appendix of the document you have. And it changed the color from the old wine to what I would refer to as a golden sunset, or almost a rose gold. You know, there are different kinds of gold. There's white gold, yellow gold, rose gold. Well, you'll see this print, it is very beautiful, this sort of rose gold color. It's very interesting. Of course, a standard toner is gold toner. And as gold toner is known to do, it shifted the color toward the blue. No surprise there. It does that for most other media as well. And it made it more magenta. Now, a strange side effect was something that looks like a clumping of grain or a tonal banding. Compare how smooth the tones are here with how broken up, grainy, clumpy they are here. More research needs to be done, perhaps on a full-size print. And again, hopefully you'll have an example along with this video, of what happens when you tone an entire print with a gold toner. It just takes on a sort of, this is going to be a very strange word, a chunky look. You no longer seem to have the smoothness of tones, so this should be very interesting. Now, I came up with an idea. Of lead toner. As I mentioned earlier, all of these processes, I should say, the uranotype is like the cyanotype in that the final image is made of a ferrous cyanide compound. In cyanotype, it's Prussian blue. It's ferric prussate. In the uranotype, it's uranyl prussate, uranium ferrocyanide. And so, as I mentioned earlier, many things are parallel. I discussed earlier that you can use dichromate as a contrasting agent, and that the water wash has to be slightly acid or at least neutral, or you lose your Dmax, just like with cyanotypes. So I also thought to myself, as a result of a conversation with Bob Schramm, where we both said, geez, I'd really like one day to try toning a cyanotype with lead acetate, because it makes a very interesting color. And I thought to myself, well, that sounds like fun. Okay. I'm not sure what color toning a uranotype with lead acetate would produce. What I think might be interesting is that toning changes the color of an image by at least partially coating the surface of the image metal particles. Let's say you have a silver image. It's particles of silver metal producing your silver image, like a salt print, albumin printing out, or your standard silver gel enlarging papers. And then you tone it. The gold adheres to the surface of the silver and makes it more inert, but also it changes the way that it either reflects or scatters light, and that's what changes the color of the image. Now I thought to myself, what happens if we get lead to at least partially, if not totally, surround the uranium ion in the uranyl prussate? What color will it go? I don't know. But anyone watching who has either had a dental x-ray or any other form of x-ray knows that they put these big, heavy bibs on you when you're getting a dental x-ray to protect your thyroid and everything else. And they're made of lead. And they absorb radiation, whether it's x-ray, gamma, alpha, beta, a little less neutron, but they absorb radiation. Now, wouldn't it be interesting if by lead toning a uranotype, you could reduce the very low level of radiation to almost zero? And this is something I would really like to experiment with, and hopefully I'll have a sample for you by the time I FedEx up this video and the other sample prints. It could be a very interesting thing that we could actually reduce the radiation of the uranotype to near zero or near to background radiation. However, that's sort of a Pyrrhic victory, because not only will you then be working with uranyl nitrate, which is highly toxic, you'll be working with lead acetate, which is just as toxic. So I think you're spending a lot of effort with highly toxic things to reduce something that is not that dangerous in the first place, but it still sounds like an interesting bit of experimentation. Just to summarize a few observations and conclusions, I did a test on the time between coating and the exposure and development of the Crane's platinotype natural paper. I did one print 2 hours after I coated it. 2 hours later, I exposed and processed it. And the next print I exposed and processed it more than 12 hours after coating it. I found that the print that was exposed and processed 2 hours after being coated was warmer with a redder color. It had 20 steps on a step tablet. That's a 0.15 density difference step tablet. And that's a total scale of 3.0. That's a delta log E scale index of 3.0. That's a whole lot. The one that was waited 12 hours between coating and exposure and processing had a higher Dmax. It was actually darker, but it was slightly cooler. It had lighter highlights as well, and it yielded 18 steps, meaning a scale index of 2.7 or a delta log E for exposure of 2.7, which was a little bit less, but it was snappier looking. So oddly enough, if you want a flatter, redder image, expose and process soon after coating, as soon as the paper is dry. If you want to slightly snap your image with lighter highlights, deeper shadows, slightly less red, then you can wait. You coat one night, print the next day. I think the major conclusion on making uranotypes in terms of what kind of negative you use is that you need a negative with a very long scale, 2.7 to 3.0, to make a uranotype print. Now, this wasn't any big deal in the days when people made glass plates, or they made what are they called? Albumin negatives, or collodion negatives. The original negatives were incredibly dense and had very long scale. I curated a collection of negatives here in Barbados that were made between 1880 and 1937. They were all glass plate negatives, and believe me, they were very difficult to print with standard silver gelatin paper. I used a 0 filter, and I often had to kick in another 40Y to hold any of the scale. Scanning them was also quite a challenge because of the long density range. But they would print beautifully. As a matter of fact, there's another idea for something to do, is to borrow one of those original negatives that I worked on, and see if I can make a beautiful uranotype print from that glass plate negative. When it comes to processes like uranotype and perhaps lead acetate toning, I'd rather err on the side of caution. Some of you may think that I've overdone the precautionary measures, but some may think I haven't done enough. I guess I get this from my pilot training, from my flight training. There are no fender benders when you're flying. You can't run low on gas and pull over and go get a tank from down the road. The consequences of errors, or the consequences of being inattentive in flying, are dire. Flying is one of the safest modes of transportation, but mistakes are costly. I feel the same way about dealing with uranium and lead. So I'd much rather be overcautious than under. Also, in terms of due diligence, I have provided what I hope are sufficient warnings. In the documents you received should be the MSDS from Sigma Aldrich, I believe, for uranium nitrate. It makes it very clear how dangerous it is. You're adults, you'll make your own choices, but at least I've done my job of letting you know what you're dealing with. This has been really an interesting bit of research. It's been great fun. I wish I could have been there in person, but I hope I haven't bored you with these talking head videos, and I hope the information I've shown you is interesting, and I hope the prints that you will be able to look at will stimulate you all into trying this process. Those of you who feel you can deal with the risks, into trying the process, experimenting with it further, and making some beautiful uranotype prints. In the not too distant future, when I I hope to make some larger prints. My platinum palladium prints are up to 15 by 19 inch images on 20 by 24 paper. I'd like to try to do the same thing here. One topic I haven't dealt with yet is the accessibility of uranyl nitrate. I got mine on eBay, and it can be shipped to you via UPS ground. There's no problem whatsoever about shipping it UPS ground. It comes with a little label that says, "Warning, may have slight radioactivity," and it just shipped. I had some sent from various suppliers in the U.S. to a U.S. address that then forwarded it to me here in Barbados. So it's accessible. If you have an eBay account, you can do that. And I've been trying to encourage Melody to seek a quantity supplier so that then she could sell off smaller quantities at a reasonable price. We'll see. I guess the trick with it is, folks, you are those who would be the demand, and Melody and Richard would respond to that demand with the supply. So let's hopefully we can all move forward and play with this process some more. I'd love to see more of this being done. Thank you very much for your time, and come visit someday. Come see beautiful Barbados. Thank you. Bye-bye now.